Really, lists are a fundamental portion of Python, and we could have been lecturing for like 4 weeks on the use of lists. Instead, we're going to spend 1 day on it. But we broached the topic last week. And the idea of a list is that it's just a series of data, elements. There's also something known as a set. And a set you declare with the curly braces, but with a list you declare with the square braces. So I'm going to pop open idle and play with a few lists. Okay, so like scores is equal to square brace 90, 80, 100. If I want to figure out what the first score is, I just use the index value of it, score 0. If I want to get the first and the second item, I can do scores 0, 1, and that'll get the first and the second item. If I want to get the last item, I can use scores -1, only in this language. If you want to sum those scores, you can use the sum method. The sum of those 3 scores is 270. And of course in a program I would actually assign that to a variable like that, and then do something with it. If I want to iterate through the scores, I use a for loop. For every, and then you just give it a variable name, and the variable name is not significant except as much as you want to give it significance. You can call it anything you want. For every score in scores, print that score out. Now I didn't have to call it score. It didn't have to match. It didn't have to match that. I could have called it for X in scores, or for I in scores, or Fred in scores. So this is how, in general, you enumerate through a list. And you'll see this syntax an awful lot in Python. If you open up a file, you can use a for statement to step through the file. If you open up an internet socket and read from the internet, you can use a for statement to loop through what you've just read. If you want to add all those values together by yourself rather than use something called scores, I set a variable tally equal to 0, and then I write a for loop that will add every score, except I'm going to change it to X, make it easier to type. And then tally is plus equal to X. And as soon as that runs, if I print tally out, so this is a very common thing to do. This is like fundamental to programming in general, not just in this language. Is that if you have some kind of dynamic data structure that's a list, an array, something like that, you can iterate through it and get all the values out and do things with it. Whatever you're going to do, you're going to print them, you're going to sum them, you're going to print a payroll check for that person, a mailing label, whatever. So to create a list, you declare it like that. Series of values between square braces. And unlike some languages, they do not have to be the same data type. If you want to mix and match data types, you could do that. Kind of silly, but if I want to do, D is equal to Joe, 33, false, whatever, 3 different data types completely, it doesn't mind. So if I print out D0, it'll print out Joe. If I print out D1, it'll print out 33. If I print out D2, it'll be false. Usually when you're dealing with lists, they're all of the same type. So a list versus a string, they're really very similar because a string is just a sequence of characters and a list is a sequence of elements. 2 differences between lists and strings. Lists can hold any type, whereas strings are sequences of characters. Strings are immutable. You can't go and insert a character into the middle of a string. You can build a new string that had something there in the middle. However, lists are mutable, very changeable. You can insert elements into the middle of them, or append elements to the end, or delete elements from them. You can get an out-of-range error if you try to access something past the end of the range. If your list is 3 elements long, like my first one was here, scores is 3, so I can set scores sub 0 equal to a value. We decided they made 100. We can set scores 1 equal to a value. They made 100 on that exam. We can even set scores 2 to a value. But scores 3, since the list is only 3 elements long, we can only change 0, 1, and 2. The third one blows up. List assignment out of range. If you just wanted to find out the length of that list, you could do that. What is the length of the scores list? So if you ever needed programmatically the number of elements in that list, you could get it. Why might you need that? To calculate the average, for example. You could do the sum of scores divided by the length of scores, not the sun. You know, average is equal to the sum of scores divided by the length of scores times 100, so that we could, you know. Yeah. There we go. And then print out average. Well.
What?
Let's try that again. Okay, what's the sum of scores? What's the length of scores? Oh, that's because they're already in 100s. I'm not calculating percentages, so I didn't need to multiply it by 100. That's if you're calculating a percent, not an average. I don't know why I did that. So average is equal to the sum of the scores divided by the length of the scores. And there we go. It's 100 because we assigned all 3 values equal to 100. Sometimes you have input in a string that you want to convert to being input as a list so that you can process each word. And you do that with the split method. You know, every string has a split method so that you can split it up based on some certain value. So, for example, here's my new sentence. I'm going to call it S for sentence or string. S is equal to Mary had a little lamb and some wine to go with it. Okay, so now I'm going to create a list that is each one of those words. So S.split creates a list of those words. If I wanted to store it in a variable, S.split. Now, if I wanted to print out each word on its own line, I could do that. You know, that'd be another for loop. For every word in the words list, sorry, I keep slipping into the Java syntax. For every word in the words list, print that word out. And there we go. Each word was printed on its own line because we were traversing the list item by item. So W is the variable name that receives each word in turn until the list is done, and then it stops processing. Now that is a list of strings. So if we needed to do some numeric processing on it, we would have to convert them to integers or floats or something while we processed it. Now, if you want to split based on something else other than spaces, you can pass in parameters, which are your delimiters. You can say, I don't want to split based on spaces, I want to split based on something else. So, for example, say I want to split on periods. Here's my new sentence. I love Star Wars, especially Jar Jar. There we go. Now I want to split that into 2 sentences. I forgot to end this in a period, which I really wish I had. However, I think that I can just use this as a delimiter and it's still going to split it into 2 sentences. So let's find out. What I'm going to do is hope this works. S.split on periods. And there we go. We got a list of 2 sentences. Now, I probably would have had white space in there, and we might want to trim off the white space, you know, and there are ways to do that. Say I had a sentence that, if I had a string that looked like this, title is equal to Star Wars, and it had some extra spaces at the end. How do I get those extra spaces off? I believe it's either title.trim or title.strip. Nope. Title.strip. That removes that. So if I had a sentence like this, I love, let's do this again. I love Star Wars. It is so cool. I want to grow up to be a Jedi like Spock. Now I'm going to split that. And I'm going to split it based on periods. So some of the sentences are going to have, spaces in front of them, which may not really be what I want. So here's my list. L, I'm going to use capital L, is equal to S dot split, the whole thing based on periods. Now when I print out L, I'll see that it's split into 3 sentences. However, some of them have spaces. Let's try stripping the spaces off of either end. So I'm going to write another for loop. And you can also do this programmatically in a single statement. But the syntax for it is considerably more complicated. For every word, or actually for every whatever it is in the list, print that sentence stripped of white space. And there we go. Well, we can't really tell, can we? Let's try it again, but tack on something at the end. For every X, for every sentence we find in our list, let's print out X dot strip followed by, I don't know, some kind of marker to denote the end of the sentence, like an exclamation mark. Let's give that a shot. There we go. And so it did strip it of spaces, ending and beginning spaces. So the input's pretty clean that way. So making notes about things that we wanted to make notes of, lists, how to define, how to split a string into a list with dot split. You can specify the delimiter. What if you have the opposite? What if you have a string, a list, and you want to build a sentence from it? So here's my new list. I love, Star Wars. And I want to build a sentence out of that. I can use the join method in order to build those back up together. So string or sentence or whatever is equal to L dot join. Not capital J. I don't know where that came from. There we go. Ew. List object has no join. What have I done? Okay. The syntax for it is really odd looking. You have to call it based on a separator string. And then you can say like this, space, dot, join, and then you can pass in the list of things that you want joined. The syntax is very kooky. But it did it. It took this and it put that character between every word in our list. So here's our list. And this built the list from it. I apologize for that syntax. I did not create it.
Variable, like lowercase l equals blank space dot join.
Yeah, absolutely. Yeah, like sentence is equal to join list. Then print sentence. Is join a method available all by itself without giving it a delimiter? Let's find out. S is equal to join my list, please. Nope. You have to do it in this goofy syntax. But that lets you specify what the delimiter between the terms are going to be. If you don't want them to be spaces, you could put commas or whatever. So, sentence is equal to join, a comma, dot, join. Instead, I'm going to join my scores list. I'm just curious if I can join a list that is not strings. It should not let me do that, but maybe it'll convert them to strings. No, I got an error. It said expected string, but integers found. So I'm not surprised that that failed. S is equal to, comma, dot, join. Let's go ahead and build our, there we go, based on our list. And then when we print out S, it says I love Star Wars, but it's separated by commas. So you can join and you can split. So we can split a string into a series of characters, a list of characters, if you want every character to be its own separate thing. So like title is equal to Star Wars. And now I want a list of all the letters in that. And that's equal to title, is equal to a list made of that string. Now when I print letters out, I see that it's a list of characters, like that. So we're going to write an itty-bitty little program that is going to encode this. Well, let's print out. Just a second. I would have to go fetch my code that did that. Instead, I'm going to use Google. Alrighty. Okay, there are two functions that you can call in order to manipulate ASCII values inside a string. You can use CHR, that will turn a number into a letter, and you can use ORD, which will turn a letter into a number. So for example, I could do this. I want to find out what the ordinal value of the capital A is. And if you've ever stared at an ASCII chart long enough, you know that the capital A is a 65. Okay, cool. Well, then 66 is going to be a B. So let's print out the character value of 66. And it's a B. So let's create a script that uses these two things in order to convert a sentence like this, or a series of letters like this, into something that has been enciphered by shifting them up. So that A's become B's, and B's become C's, and C's become D's, and so on. So I'm going to do new file, do a save as always, not in your Python directory. I'm going to call it Caesar.py. This is known as the Caesar cipher. People used it even in Roman times because it's really easy to do. You know, you just take every value and you shift it by 1 or 2 or 3 or 4 or whatever, and then you wrap around at the end, like a Z becomes an A. Okay, so for this to totally work, we're going to need to know a few things. Let's find out, without hitting an ASCII chart, what the ordinal values of big A, little a, big Z, and little z are. So, print A, comma, ordinal value of A. And let's do that for capital Z. This is not part of the cipher, but we're just learning the parameters of the ASCII character set. Now I want to do lowercase a and lowercase z. So I'm going to run this, and I will see, there we go. The ASCII character set from capital A to capital Z is 65 to 90. We're going to use that as our basis for determining whether we're going to shift that character or not. Python also gives us, functions that would tell us if that is a character or not, but we're going to do it mathematically. And the lowercase letters go from 97 to 122. So if our ordinal value is between 65 and 90, or between 97 and 122, we want to encipher it. I'm going to copy those four lines and paste them as a comment into my script program. Now that I know that. Okay. So I'm going to make it a multi-line comment. I'm just going to put 3 apostrophes there at the bottom and top of it. Okay, there we go. All right, let's ask the user for a sentence. Or let's just hard code a sentence. That'll be pretty cool. I'm going to call it source. I don't know if that's a great term for what I'm going to do, but now I'm going to enter a sentence. This is a sentence. It can be anything you want. Now let's turn that into a list. I'm going to call it character source is equal to, or maybe I could just call it char s. Yeah, char s is equal to the list version of source. And to make sure I haven't gone off the rails, I'm just going to print out char s and stop at that point. I find that if I run the program a lot, I catch my errors much more quickly. Okay, so that worked. I don't have any syntax errors yet. And this stuff up here, print A through Z, I can comment all that out as well. That's no longer necessary, so I'm going to use the triple apostrophes to comment that out as well. There we go. Now I want to run through that list. And every character in that list, I want to shift it up by a certain value. Let's just do 1 to begin with. So I'm going to make a variable called shift, and it's the number that I'm going to shift by. It could either be a positive or a negative number. In this case, yeah, let's go ahead and use a for loop to iterate through our character list for every character. Wait, I'm going to define a character destination list now first, so we can start adding on to it. Char D for destination, or encoded, or whatever, is equal to empty set. Right now there's nothing in it. Now for every character in our char S, first let's get the bare minimum going down. Let's just copy that character into char D. So char D dot append, is that going to work? Append ch to it. And then print out underneath that char D. Let's make sure that it is a duplicate at this point of character S. Kind of taking baby steps here. Yep, that duplicated the list of characters. However, now that we're in there, we can mess with this mathematically. We could add values to the ordinal value. Now it'd be nice to put this inside a function, but I'm not going to. I'm just going to kind of brute force it right here. X is equal to the ordinal value of that character. Now if X is between our range, if X is a letter, if X is less than or equal to 65, and X is greater than or equal, no, I've got that wrong. If X is greater than or equal to 65, and X is less than or equal to 90, I should just really be using a function to determine if it's a letter or not. That'd be a lot easier. But I like seeing these numbers just to get you used to seeing these numbers. What I want to do is I want to write, yeah, that'll work. Okay, so if any of those are true, we're going to say is letter equals true. If none of that is true, let's check for the other range, the lowercase letters. So elif X is greater than or equal to 97 and X is less than or equal to 122. And by the way, I forgot my colon on that if statement, so go back up and add a colon on that if statement. Then is letter is also equal to true, else colon is letter equals false. If it's not within the range, okay, now we know whether it's a letter or not. If it's a letter, we want to do something to it. We're going to add something to the ordinal value of it. We're going to add the shift value. I don't want to go up too far. There. I believe that's all the useful code of this. Okay. So if it's a letter, if is letter, colon, then x plus equals the shift value. That is something I really don't like about what I'm doing here.
Can we get rid of the elif statement and just make our range from 65 to 122?
Yeah, we can. But what I want to do is I'm going to take these is letter comments out. I'm going to take this else statement out. But we are going to modify the value of it right here. If it's between 65 and 90, x plus equal to our shift value. But if we've exceeded, if x is now greater than 90, we have a problem. If x is greater than 90, then we know we're past z. And so we need to subtract the length of the alphabet, which is 26. X minus 26. And we also need to check the lower end. This really should be a function. I think we're going to wind up yanking this code out and making it a function. If x is less than 65, that means it's less than an a, and we better add 26 to it. So the reason we're doing this is so that, if we're at z and we add 2 to it, if z is 90, then now that letter is going to equal 92. There is no letter value 92. It's a punctuation symbol or something like that. So we're going to subtract 26 from it, and we'll find then that that is equal to b. Also, if we were subtracting values from it rather than adding values to it, then, like a minus 2, 65 minus 2 is 63. We are off the map here of the Ascii chart. I'll load up the Ascii chart in a second, show it to you all. So we have a 63. That's too small. It's not between that range, so we have to add 26 to it, and we'll find out that that's a y, or a z. Because if you take 2 steps back from b, b goes into a goes into z. Or if you're at y and you want to take 3 steps forward, z, that's 1 step. A, you have to subtract 26 to get to the very beginning of it, is the 2nd step. And then b is the 23rd step. The 3rd step. Okay. And this so badly needs to be in a function. I don't even want to handle lowercase letters right now. So I'm going to delete that line, and I'm going to only put uppercase letters in my source line. This is a sentence. That's going to simplify our code at least a little bit. Okay, so now we have a new ordinal value. It may or may not have changed. If it was a lowercase a, if it was between an uppercase a and an uppercase z, then we modify it by the shift value. And if it becomes greater than z, we subtract 26 to get it down to the beginning of the alphabet. If it's less than a, we add 26 to get it back up into the alphabet range again. Okay, so now we want to append the ordinal value, the character value of that to our list. And then we're going to print it out. Now there's every likelihood that I've munged this up and it's not going to compile cleanly. It did. What do you know? I'm going to put some spaces in it to try to make it a little bit easier to read. And I'm going to add some comments. Shift by the specified value. If larger than z, subtract 26. If smaller than a, add 26. And by the way, these look like magic values, but we could just replace this with ORD, capital A, and we could replace this with ORD capital Z. I'm not going to do that though. Here's what the Ascii chart looks like. Most of y'all have seen this, but you know, you go out here, Ascii table, there you go. You know, the decimal value of an uppercase A is a 65. So if we subtracted 1 from it, it'd become an @ sign. Well, I don't want to print an @ If I've subtracted 1 from it, I want to loop back around and make it a Z. So if it's less than 65, we add 26 to it. Well, what's 26 plus 64? 90. So we're down here and it's a Z. Same idea. If you're at 89 and you add 2 to the value, well, one of it would get it to 90. The second one would get it to 91. Well, that's not a letter anymore. So if it's greater than 90, we subtract 26 from it. What's 91 minus 26? That's 65 again. So that now we're there. So we're rotating it, you know, around a very common cipher in the early days of the internet was something called ROT13. Why 13? Because there's 26 characters in the alphabet, so you're just shifting it up 13, and then you're shifting it back down 13. So that might be fun to do, change our shift value from 1 to 13. Okay, so if you have this typed in correctly and you run it, what you'll see is this says this is a sentence, but then our enciphered, I can't really call it encrypted, our enciphered version of the sentence has every letter increased by 1. You know, and so instead of an A, there's a B. Instead of an E, there's an F, and so on. You know, and we could throw in some ABCs and XYZs and whatever to make sure that works. Now, we also said how to join this stuff back into a sentence. At least I think we did. If we have a list and we want to join it back into a sentence, then we use the join method. Okay, so our original input was called source, so I'm going to make this one called destination. These are really bad terms, but destination is equal to empty string. You know, quote, quote, dot, join, and then I want to add these characters to it, and I want to print that out. There we go. So that is the enciphered version, shifted by 1. Now, sometimes in classes in the past, I have given you a string that has been encrypted in this fashion and asked you to decrypt it. Figure out what shift value makes it work. You know, and you could just run the program, you know, 26 different times, increasing shift, you know, to 2, 3, 4, 5, 6, 7, 8 until you find it. Or you could write a for loop that would iterate through this. So I'll give that some thought, but okay, so really what did I want you to see out of this? I want you to get a few ideas. I don't think the book adequately really hones in on the fact that you can manipulate, you know, each element of a string in this fashion. You know, the slide says that strings are immutable. Well, yeah, but lists aren't. So you can load up the entire string into a list, and then you can modify each character in the list, or whatever character you wanted to, and then you can build a new string from it. So if you wanted to remove all the periods from the strings, well, there are methods to do that, but you know, you could do that. Okay, is this working for everybody, or are you getting syntax errors, which is totally okay? Good for you? Good for everybody? Okay, cool. So I'm going to put a comment up here that this is Caesar's cipher. I think cipher is actually with an I. I'm trying to make it look like cyber. The shift value we could ask for, the sentence we could ask for, and we might also want to shift lowercase letters. If we were going to shift lowercase letters, it'd be a good idea to turn this into a function. I don't know how much time we want to spend on doing this. Yeah, let's turn this into a function. Okay. So I'm going to yank this code here. I'm going to cut it. I'm going to leave a little placeholder. And up above the line that says Caesar's cipher, I'm going to define a function called shifted. Define shifted. And it takes a value x and it performs this math on it. But it's also going to need to take two other values. It's going to need to take that 65 and that 90. Because we want this to also work for lowercase letters as well as upper. So let's make two more variables, one called lower and one called upper. And replace all the references to 65 with lower and all the references to 90 with upper. Then back down here, where I had this little placeholder, I'm going to say x is equal to shifted. I'm passing in x as my first parameter, and then our lower value is 65, and our upper value of our range is 90. Now that's enough of a change for it, I think. Yeah, why not? Let's do if x in range. If, so above that call to shifted, I'm going to do if I forgot to put a return statement on my shifted method. So down here at the bottom, I need to return x because we've modified it. So if it's not even between the range of lower and upper, we don't want to touch it. So my very first statement of shift is going to look like this. If not x in range lower upper plus 1, because unfortunately, you know, the range statement generates a series of numbers which is inclusive on the lower end but not inclusive on the upper end, then don't do anything. Just return x. Just bail out instantly. Okay, so there's our shifted method now. That way we can call it, and if it doesn't fall between a range, it doesn't do anything to it. It returns it untouched. But if it does fall within that range, then it goes and does all this. And the only reason I use not is so that I could bail out early, you know. Simplified the code a little bit. I didn't have to indent everything here. Okay. So down here, I'm going to say x is equal to shifted, x 6590, and then I'm going to do the same thing for the lowercase letters. Shift, x, shifted, and then lowercase letters are between 97 and 122. I wonder if this is going to work. Yeah, that's pretty good. Now the only problem with the shift function now is that it's hard-coded to always shift 1. That's not really too cool. In fact, I'm not sure how it's finding shift because shift is defined lower than the function. But we need to pass that value of shift in as a fourth parameter. So I'm going to modify the definition of shifted to allow us to pass in the value to shift it by. And then I need to go and I need to modify my call to shifted to have the same change. That way we could change it to 2, or we could pass in a -1 and it would un-cipher it. All right, I really don't want to take this any further. We could monkey with this all day in order to get it so that you passed in a sentence. This whole thing should probably be inside a function. But we've done enough of this so that if I decide to throw this as a last-minute assignment, then you will recognize all this code. So what would I want to do? Just think to yourself, if you were going to write something that would encipher and decipher, a sentence, what kind of function? What would the parameters of the function need to look like? I'm not going to actually write it, but suppose I was going to write a function called in Cipher. What would I want to pass in? I would want to pass in the source sentence, right? And then maybe a shift value. And then it would need to return the destination string. And so you could pass it in a positive shift value to encipher it, and you could pass in a negative shift value on the results of that to decipher it. Okay, now that it doesn't fit on one page any longer, it's going to be harder for y'all to see what I wrote. Anybody getting syntax errors or weirdness, or need me to scroll it up and down? Is it working okay?
Where?
Yeah.
I have no idea. It works. I'm just not getting what?
That is working.
I'm getting it.
Is your final E?
We have to go and modify,
After I turn this into
add a
function,
fourth parameter here, yeah, comma shift on your definition line. Define shift, there needs to be a fourth parameter there. You got yours going? Okay.
Yeah, okay. Yeah.
Y'all are all copacetic?
No, might as well. That's giving me an E.
Yeah, I broke it.
Okay, let's see.
You don't have your destination.
Yeah. Standard.
Destination is equal to 0 dot join character D. That looks right to me. I don't see. It's not working. Oh. Okay.
After we made it to function, it stopped shifting. This is my x equals word ch need to come up here into the function. No, use do.
That's so hard to keep stroke F5. Oh. We were only adding one character to the array, whatever the last one was, because these weren't indented.
Yeah, I can't see the indent.
I'm sorry.
Oh, there he goes.
All right, remove my extraneous prints. Okay, cool. Alrighty, so we spent a long time on looking at the split function, which splits based on a delimiter. We also looked at the list function. We looked at ORD, which converts a character into its ASCII value. And we looked at CHR, which converts something from its ordinal value back to ASCII. I know y'all have already seen the range statement, so that's not miraculous. And then we did the join function, where if you do something like this, it would separate every word by a space. You know, join all the strings in L separated by spaces. Or you know, do that. No empty space, empty string. Join all the strings in L with nothing between each string. And what did the list function do? If you do list L, or L is equal to list, and you pass in a string, splits the string S into a list of characters. I will go in and modify these notes a little bit more, but this stuff should be fresh in our mind. Okay. Determining the list length, LEN. And then there's sum, if you have a, and then min, and max. So list.sum, sum the list in, get the minimum of the list, get the maximum of the list, and they don't only have to be numbers. You can't sum a list of strings, but you can get the minimum string if you want, which is kind of weird, but, you know, open up a new, there we go. So, you know, like the minimum value, let's make it, movies is equal to Star Wars, comma, Star Trek. And we're going to find which one's better. Max of movies. It thinks Star Wars is better. That's just because W is higher than T. You know, minimum would show Star Trek because T is less than W. But we cannot do this. Some movies because they're not strings. I mean, they're not integers or floats. To loop over the values, we've seen this. If you wanted to print it out and not, yeah, this is a different concept, but not that different. If we have a list that looks like this, L is equal to, you know, 1, 6, 8, 9, 3. And then you want to loop through the list, you could do for I in range length of L, and then you could print out the list item at that specific position. This is the index value right here. The index value of that specific item in the list. Now that syntax is nastier than what we were just doing. You know, we were doing this for every value in list, print value, right? These two do the same things. They just do it slightly different ways. This one creates a counter that counts from 0 to 1 less than the length, and then uses that as an index into the to specify the element inside the list. And this one, you know, copies each value in the list into a temporary variable called value, so it can print it out. So two ways to traverse a list. One is by index. The other is by values. List aliases. If you do something like this, scores is equal to, and then you give it a list, and then you say another variable is equal to scores, you actually just have two references to the same list. Like you have two street signs pointing to the same house, to the same street. Just because you have two signs to it doesn't suddenly mean you have two streets. You still only have one Oak Street, but you have two street signs that are pointing to it. So if you do this and then you change scores, values will also be modified. So scores is equal to, well, no, we've already got one called movies. So I'm going to make another list, and it's going to be called T. But it's not another list, it's just a reference to the movies list. So now when I print T out, there we go. Let me scroll this way up. So T and movies point to the same thing. So if I pin something to one of them, what's our other favorite movie? The Godfather. T is now a list of 3 items. But what about movies? It's also a list of 3 items because they're pointing to the same thing in memory. You add a new house to your street. Those 2 street signs are pointing to that street. There's 3 houses, on that street, regardless of which street sign you're looking at. There's 3 items in our list now, regardless of whether we're referencing it by that name or by that name. Modifying alias list, you can change the values of them, but we've already talked about that. You just specify the index value and you can put a new value in. List operations. Appending. We did this last week, but since it's not on the video, David, it's a good idea to mention it again. You can append things to a list. You can insert an element at a specific element index. You can find one. You can remove it. You can concatenate 2 lists together. Sum, maximum, minimum, and sorting, and then copy. So here we go. We've created a list called friends. We're going to append some names to it. Append Harry, append Emily, append Bob, and append Carrie. And by the time we're done, the list will say, in order, Harry, Emily, Bob, and Carrie. Inserting an element. You specify the index value. So let's say that we really like Jaws and we want it to appear before Star Wars in our list. Okay, so list.insert at element 0, Jaws. Except it's not called list over here, it's called T or movies. So movies.insert, there we go. Now if I print out movies, Jaws is at the beginning of the list because we specified index value 0. You can find an element with the in operator. The in operator just returns true or false if it's actually in there. So let's check our list to see whether it's got the best movie ever, Ferngully. So here we go. If Ferngully in movies, print yes. Else, print no. Sad face. Okay. But Ferngully was not in the movies list. So we did not print yes. We printed no. If I substituted Jaws or the word Star Wars or, Godfather in there, it would actually work. Removing an element. You can use pop. If you pop without specifying an index number, it removes it from the end of the list. If you pop but you do specify an index value, it removes that specific element. So I've decided that I don't like Star Trek anymore. I'm kind of mad at J.J. Abrams. I'm going to remove it from the list. So, which is the index number of Star Trek?
2.
Yeah, because that's 0. That's 1. So Star Trek is 2. So I'm going to do movies.pop, element number 2. That returns Star Trek because that was element 2. And now if I print out our movies list again, it's missing that element. And we are out of time. Let's go ahead and upload our Cipher script. I'm going to make a Dropbox for that. So here's our final version of the Caesar script. All this stuff is commented out, but I'm going to put, who programmed this, your name here, or a programmer. And this is in class assignment H. All right, I'm going to scroll down this, give you a chance to make any final corrections you need. You can pause your screen as you type it in. This is the shift it method from here to here. And This is the main code that uses that method from here to there. When you get it done, go ahead and upload it to in-class H. There we go, Caesar's Cipher.